This is only if these are all conductors?
Yes. Yeah, if they're insulators, then an insulator will hold on to the charge. It doesn't let go. So charge does not apply.
So that means the Kirchhoff's loop law only applies when it's conductor.
No.
Let me pause for a second.
So we will get back, because we will have resistors and they're definitely not conductors. And what this is saying is that if you go around the loop, as long as you come back to the same point, this will become zero.
Oh, but
Yeah.
so that one.
Yeah. So there may be voltage drops or increases when you have batteries and so on, but you will have, when you come back to the same point, it has to be zero. Change has to be zero.
Doesn't matter if that's conductor.
It does not matter, yeah. For now. When we do magnetic fields, we have non-conservative forces, so the loop rule does not even apply. So we will, see, everything I tell you is true until we move on, right? It's true under the circumstances it applies. It's, everything's true, except, when you only apply it at the, the situation it applies to. If you try to apply it to a situation where it doesn't apply, then it doesn't apply. All right, so I have 5 more minutes that I wanted to talk about batteries. So, we have batteries, and they're a source for potential difference. And you have, for example, a AA battery or a AAA battery, or I think D cells or whatever they are. So, or the wall, you can plug your computer there to charge it, and so on. So what do batteries do for us? Well, they're a source of potential difference. So here is what happens. Can I erase this part here? No objections? No? Okay. I mean, the battery has things inside it, right? And what are those things? Some chemicals, right? So there are chemical reactions. And as far as we're concerned, let's say here is I'm trying to draw a battery, like this. Usually in a battery, where is the positive end? I'm trying to draw it up like with it.
On the what?
Yeah, this is the plus, right? Yeah. Yeah. So this is the plus, and this is the minus. Now, if you have pluses and minuses, just sitting there with nothing, they would just stick to each other. Now, to separate them, to make this negative and that positive, there has to be some force that forces them. And somebody has to do work to rip them apart. And chemical reactions happen here, and we will just say chemical reactions happen to separate the charges. For 2 reasons. One of them, because that's what really happens. And the second reason, I don't know what technology is used. And so I would just take the approach of our book and just say, there are chemical reactions that we're not going to care about. Here's what they do for us. They just separate it. We have a plus, we have a minus, right? That's it. Or not just a plus. We have pluses here, and this is the minuses. Okay? So what the battery does, it maintains a potential difference between the 2 ends. So if this one is 0, this will be, if it's a 1.5 volt battery, this will be 1.5. So what matters is the potential difference. Again, I mean, what's my height right now? I mean, at what height am I standing? At 0, because I want to define my surface, here to be the 0, right? At what height am I standing relative to them? They will think I'm at negative, right?
Mm-hmm.
But the difference is constant for everybody. 1.5 minus 0 is 1.5. If this is 1, this will be 2.5. Because the difference between them has to be 1.5. That's what a battery does. Okay? If you put 2 batteries next to each other, if you put a battery next to a battery like this, and let's say both are 1.5, what would the potential difference then from here all the way here be? 3. Would be 3 volts, yeah. And the symbol for a battery, so the symbol for a battery is in circuits, interestingly, it looks like this. That's the symbol for a battery. And usually you have a wire here and a wire here to connect it. Here is the question. Where is in this symbol, which end is the positive end of the battery and which end is the negative?
I guess the
The left
right
one's
is
a positive.
positive.
Short one.
The bigger one is positive.
Yeah, so it's not intuitive at all, but this is a symbol that we're going to agree on. This will be the minus and this will be the plus, which doesn't really, you would think that this will be the plus, right? The tinier one and the broader one will be the minus. But that's how battery is, the symbol is drawn in a circle. It's not right, it's not wrong, but that's the symbol that we're going to agree on. Okay? Huh? Yeah. So, I'm trying to jam, let me do this. I think it's reasonable to probably just stop, because if I discuss a new thing, it's not going to be reasonable. I would stop, I would just,